So thank you for your participation in this first webinar. The focus of these webinars is the data collection in the field applied to the organic food breeding sector. Okay. So we are developing three specific webinars with the objective of presenting new tools and approaches dedicated to the organic food breeding sector. Different innovations will be presented. So these webinars are also developed to support the implementation and to also collect feedback from users if we have users of innovations in the audience. So today, the focus is on digital tools. One is the Breeders database, and another one is an open source application, FreeGen. In 2 weeks, we will have another session, a focus on social innovation. It's the participatory breeding process of apples and pears. And the last one, 26th of May, is another digital tool that will be presented, is the Fieldbook application to also collect data in the field. So for this morning, I will briefly present the InnOBreed project, the European InnOBreed project. Then we will have two presentations, one on the breeders database made by Niklaus, Bolliger, and Yann from Poma Culta, and the other one, FreeGen, from Elisa Van Dramen from the CREA. Then we will go on roundtable, and if you have any questions, we will be happy to answer them. So the InnOBreed project is a collaborative research project funded under Horizon Europe in 2022 with the objective to foster organic crop breeding and improve the performance of the food sector. In this project, we are evaluating, implementing, and aggregating different innovative solutions to promote the organic food sector by mainly on developing and deploying suitable cultivars. Different activities are conducted, like the breeding with new organic approaches, evaluating local genetic resources, pre-breeding materials, and cultivars, and introducing these varieties into the organic sector. This project is not only about technical and technological innovations, we also have organizational and socio-economic innovations. And the strength of this project is the inclusion of different types of stakeholders like breeders, evaluators, collection curators, innovation providers, farmers, and also consumers. In order to capitalize on already available innovative solutions, to identify on participative basis the most suitable varieties that could fit the organic food breeding sector, specifically due to the climate change and the consequences, to ensure that the requirements of this sector, of the consumers and also the civil societies are integrated in the innovative solutions that will be proposed, and also to highlight different practical and technological conditions to implement the different innovations that are identified and developed in the project. This project is conducted with 21 partners from 10 European countries, and 2026 is the last year of the project. So now we can start with the presentation of the two digital tools. So I will let the floor to Yann if you want to share your presentation.
So here we go. Do you see my screen?
Yes.
Nice. So first, as you said, thank you for your introduction. We are presenting BreedersDB. That's an open source application for digital management in breeding programs. And we are making it at the example of the breeding case study, Poma Culta in Switzerland. We are Yann and Niklaus Bolliger. As you know, field data collection is really important in breeding daily business, and it brings some challenges with it. And the digital acquisition and management offers actually a better workflow and new possibilities. And one of it is kind of a good automation. So the challenge to address are simpliness to use of the tool, well-structured, easy accessible, safe data, and good consistency on the level of the field data collection. So what if we had a tool that enables me to have just fulfilled the needs I've got for the management of my field collected data? Would be great, isn't it? That's our solution.
Yeah, this solution was developed in close collaboration between the breeder and IT developer. So this close collaboration, so with this we had a big improvement thanks to InnOBreed. Also, the financial of InnOBreed. We have now improved safety and good data collection and consistency. Proved and tested it in practice during 1 year. So it's really suitable and a good tool for breeding.
So that's the tool BreedersDB. What it is about, it's actually a desktop and portable devices web app that, sorry. Oh, web app. We are going to go really in detail on it and dive in it. So the purpose is, as said, field data collection, but also management of breeding programs. In this tool, the data storage is actually everything at one place, accessible online, and coherent with itself. All the collected data is actually accessible directly in your pocket. And this app is an open source application. You can self-host it or get the managed version. The whole code is free. So let's dive in with this image. I want you to get a little bit of the structure of this database. Let's start on the top with the plant. You got plant in your orchards. They got unique ID that are used in the breeders database. And each plant is part of a plant group. And each plant group is part of a plant cultivar, sorry. And each cultivar is part of a lot. A lot is actually a family that these are the seedlings of 1 year of one crossing. And one crossing can have many lots in different years. This structure you see in the name building that we use inside the database. It begins with a crossing. You've got an acronym for the mother, an acronym for the father, followed by a year and uppercase letter. crossing with that part makes the lot. And afterwards, you got a number. You've got 999 possibilities for different cultivars numbers. And in the end, you've got here a group suffix, and the whole thing is actually your breeding name. So if you got the group, you also got the crossing and the year. In the BreedersDB tool, you can use user-defined attributes. This can be text, number, dates, Boolean values, also true, false, or photos. And you use them in user-defined forms. In these forms, you can just build them as you wish and define also mandatory attributes.
Now, that's an example how we work with our tags. It's just the labeling of Poma Culta. It's proven effective in the practice. We have plastic tags with stamped unique numbers, long-lasting and reusable. And on these plastic tags, we put labels made by the printer, and these labels can also be used for fruit samples, for groups, for everything we want to label. With the QR code, it's easy to manage them afterward.
The app itself helps you to have a good coherence on the first level, that the structure of the database constrains you to just put the data at the place that it is that it's fit. And there are some other helps in the tool, like hints, warnings, or errors that can appear, and we are going to see that more in detail in the demo that I am going to show afterwards. What you do with the data once you've collected it, you want to access it, you can access it directly in the app or export it to Excel or have an automated export with Python or R. We are looking further in detail about it also in the demo that is coming. So to summarize shortly, the workflow we use is you have to have a label on your plant, but then you can create attributes and forms. You can assess the data in the fields. And then with your data you build a query, and you can analyze your data in your desktop as you wish it. So let's try it. We built a small demo version that is that you will also have an access to it afterwards. So I will present it to you how this works. So let's start with the desktop version of the app, for which I want to give you a little overview of its interface. Here you see the plants. We are here in the listing of plants, and if I click on it, you see I've got some preposition. I can create a new plant, I can eliminate one, add an attribute, assess it, add data, collect data, and analyze collected data on the level of the plant. It's the very same for the groups, where I can list them, add a new one, assess and analyze, also for the cultivars and for the lots. For the crossing, I can list them and add new ones. And I can manage here the mother plants. These are some trees that are listed there in the plants. but also marked as mother plants that have been used for impregnation that have led to crossings. I also have the pollen that I harvested listed here. So I can just go inside and see I've got some information about the pollen that I have harvested. Furthermore, I can also access to every attribution that are in the system, but also on the attribution forms and attributes that I've got, the rows, orchard, rootstocks, graftings that I defined, and some technical thing. Now I want to show you what I've got in the system, beginning with the orchards. I've got 2 orchards. Orchard 2 is empty, but orchard 1 is the one where I have some trees in it. And I've got here 5 rows and some lots. The rows have plants in them. You see the group they belong to and some other informations. I come back, the lots have cultivars in them and could also have some observations that I assessed. These are the ground data of the lots. So now we go back to the begin, and I want to show you how we can make a new attribute, make a new form, and use them. So let's start. It has to deal with the forms and attributes here. So I go to the attributes, and I'm gonna make one new attribute. So I come inside, and I'm gonna name it. As I don't have a new attribute for scab and fruit yet, I'm gonna create one. This is a rating with a minimum value of 1, maximum value of 9, and I can just add for every step I just became here a legend. So I'm gonna just add a quick legend, 0%, 25%, let's keep it simple and quick, and 100% no default value, and we're gonna make a small description. It's assessment of scab on fruit in June. Attribute type, it's an observation. I could have sample, treatment, or other, but now I want to have it as an observation. In the end, I've got a preview, I've got the legend, I've got my scales that I can use, and the small description that I need. So I save it. Now that I have this attribute, I'm going to be able to use it in a form. I could make a new form like that, new name, and so on, and add some fields that I prepared before. But I'm not going to make this because I've already an attribution form, leaf diseases, that I want to edit. And here we go. I've already attribute for scab leaf, powdery mildew, and a general note inside. Now I'm gonna take my attribute for scab fruits and add it and position it where I want to have it. Here I just specify that it's a mandatory field that I have to fill in before saving when I'm collecting data. So I created the new attribute, added to this form, and now we see how they look like. You see the small star here. This means that it is a mandatory attribute. So I save it. Now that our attribution forms are ready, we can go to the fields and collect data with the smartphone. So let's start with the desktop version of the app. So let's start. So here we are. This is the smartphone interface of the app. You will recognize it. It's really, really similar. And now we collect data. The first question is on which level we want to collect it. And now we're going to start with the plant level. So add an attribute on the plant level. We're going to select the form, which is leaf diseases that we just completed, and continue. Some metadata that I could add it here, the author, the date of the collection. I'm just going to put today. And I could insert here something to say that it is a statistical rating and sets the number of the repetitions per unit I want to assess. But I'm not going to do this here. I'm just going to continue. And now I can choose a plant, either with a QR code. Now I'm in the demo, so I'm going to just type in the number of the plant, and I'm going to take plant 1. So plant 1 and continue. Here I am in the form, in the attribution form that you see if you are collecting data. On the top, you've got the unit that you're assessing to, with the group it belongs to, and a really interesting information here with the last time you attribute this. It is really useful because if I did attribute this very plant with this form 2 minutes ago, it would just show it to me and warn me that I already did this plant, and it is just a good thing for data consistency. So let's start. We've got the attribute scab leaf. I'm going to look at my tree and say, okay, just really few. I find it. Scab fruit, that's our new attribute. I find no scab fruits. And powdery mildew, it's also good. And general notes, I can just add something, but I can also let it go like that. Now, if I did not have entered powdery mildew and I want to save it, it comes a warning because I didn't fill it in. So I go back, and as I want to fill it in, I fill it in, and now I can save it. So now I'm back on the level where I can choose the next plant. I could choose plant 2, and then I'm in plant 2, and I can go on further. So, but I want to go back because I think it's clear now, and I'm gonna make another example on another level. So I'm gonna go on the cultivar level, add an attribute on the cultivar level, go back, form selection, and I'm gonna just take the form of the fruit characteristics. I just don't change the date for the moment. And now you see on the cultivar level, I've got plenty of possibilities. Again, the QR code or the plant label ID is useful, or I can type in a cultivar name if I'm in it, and I will have the options that I get. But if I just type in my plant label ID that I also had before, plant 1, I'm gonna attribute the cultivar of plant 1. This is just useful in the field. Yeah, let's just continue. And now I'm in this form. So I said that I want to assess the fruit size. So let's say I've got the fruit sample before me, and I see, okay, the fruits are size 5. fruit weight 153 grams. And we assess the Brix, the sweetness of the juice. So we say it's 14.6 Brix. Afterwards, I want to assess the general fruit quality, and I taste it, and I think, okay, this fruit is quite good. And I could add a photo or add a note. You see, to each attribution, you could add a note. And now we are going to add a note and just say, really thin skin. That's a good thing by an apple. And now we're done. So I can just save it. And so let's say I've assessed some things, and I'm in the field, and I want to look at my data. So let's go back to the plant listing. So here we are. In this field, you can search for plant label ID or cultivar names, like something like that, or the cultivar names, and then it will give you the plants that are corresponding to them. Now I'm interested in the plant one, so I'm going to go in the plant one. First, we see here some basic data and the photos that were bound to this plant, and the attributions grouped by their type. We have observations, treatments, samples, and other attributions. And in the end here, you have also the information of if this plant has been used as a mother plant, and its name, and you would have a link to it. If I come back to the observations, these observations on scab and powder mildew are these ones that we made before, and we see them here with their date and auto. Now I want to go to the cultivar of it. Here on the top, you see the group of my plants. So if I just click on it, I access to the group of its plants. And now I'm in it, so I see more photos because other cultivars, other plants are in this group. I see plant 1 and plant 2 are in this group, and I've got again every attributions here. And I can just go one level up here, and I find the cultivar that I'm interested in, because here I see the attributions I'm interested in. On the one hand side, the attributions on scab and powder mildew we just saw, but also the attributions on fruit that we made before. And here I can just see them and also see the notes. And if it was taken a photo, the photo would appear here. And again, date and author. Let's say I realize afterwards that I made a mistake in the fruit weight, that it's actually not 153, but 135 grams. So I see here the fruit weight, and I could either delete the attribution or edit it. And if I edit it, I just can change it to my right number, and I could add a note also afterwards, value change afterwards. So, and I save it. And now I'm going back to my cultivars on this way that time to just look at this change. Here we are. And now I see it has been changed, and my note has been taken over. So that's the way you look at data directly on the smartphone or in the app. That's everything about this. We're going to talk about data export and change to the desktop version again. So here we are. So here we are again in the desktop version of the app, and I want to export some data that I've collected to an Excel sheet to be able to work further on it. So how I'm going to proceed? Let's assume I want to export data based on the level plants. So I'm going to go here and analyze and use actually a filter form that I now prepared. And here you see the filters criteria to choose on the one hand side the plants and on the other hand side the attributions. I will become a preview of the results, which I can just adjust. And now I want to just add a column because now I've got harvest date and Rosalina as attributes that I take with. And I can add a column and say number of fruits that I also want to take it. It comes in the preview, and now I can export it to Excel. So here, this is the data, how it looks like in Excel. I've made it a little nicer for you to see the important things. You've got the attributions and the attribute and the values here with the date and some metadata on which group and cultivar and so on the plant in this case belongs to, and some metadata to the attribution itself. Another way to export data is to use this button that you find in every category of levels in the listings. You see this level is everywhere and also in the attribution listing. And I can filter by a specific attribute. Now I'm going to export it without filter. Here our exported file in Excel, you've got again the attribute and their values, the entity type you see here, plant or plants group with their respective names, and notes photo, and the metadata that belongs to every attribution. Finally, I want to show you the principles of how we are going to build an automated query that we can just manage from R or Python and access to the whole database on a custom way. So we're going to need for it an access control and the personal access token that is defined here and that we're going to use in the query builder to access it. So now I'm in the query builder, and on the left-hand side, you can, on a graphical way, just choose which things you want to add to your query. That's now my query that I prepared, and I can just make a preview. And I see here that I'm gonna have attributions with their informations. So I can take this query here and paste it in R. Here, a small, really simple R script to access the database on an automated way, adapted from this web source. And yeah, it is really straightforward. I need an authenticator. I need a link, and I can set the connection afterwards. You can see here that's the query we just built before. I pasted it inside, and afterward I just can run everything, and I get this object here that is actually a data frame, and that's my data that is now in R that I can use for further analysis. So this was it for this demo version, and we actually would like to propose you to try yourself and just access to it. And here at the screen, but I'm gonna put them in the chats just afterwards. You've got the credentials to access this demo version, so you can just try yourself. You really are gonna find the very same thing that you saw now at the screen, and so you can just feel a little bit how it's like and how you can use it. I thank you for your attention. That was everything about BreedersDB, and I hope you understood what it is about and wish you a nice webinar. We are here for questions afterwards.
Thank you, Yann. Really interesting. Maybe if you have questions, we can take them after the presentation of Elisa. So maybe, Elisa, if you, the floor is yours. We cannot hear you. You're muted.
Okay, good morning. I'm sharing the screen. And can you see my screen?
Yes.
Okay, good morning, everybody. I'm Elisa Vendramin from Research Council for Agriculture, and specifically from the Research Center from Olive, Fruit and Citrus Crops. We are held in Rome, and today I want to show you our app database that we call Phrygian. In Italy, it looks it sounds very good, but it means phenotyping genetic resources. In our research center, we held the National Fruit Germplasm Center, and we maintain in the frame of FAO treaty more than 5,000 different genotypes, belonging mainly to Prunus and Malus species. And something to understand why we are maintaining all these genetic resources ex situ in vivo, because we have some very difficult questions to answer, such as climate change, population increase, and the need to protect biodiversity and environment. And because these collections are a sync gene, so there are a reservoir of genes that someone are known and sometimes are unknown. So they can help very they are very useful help to preserve agrobiodiversity, also to identify new genotypes for IPM organic farming, and also to speed it up breeding of new varieties, because we know that we have each year some new pests. Also we have this very extreme climate condition that are really difficult to manage on a farmer point of view. In the last 20 years, the genomic era speeded really up our knowledge and our capacity to produce genomic data, but we need now to have the same deep and robustness on phenotypic characterization. What does it mean? It means that we need to try to standardize the phenotypic data that we collect on field. This is a very important point, to try to identify not only cultivar of interest, but also the genetic trait and locus that yield some trait, important agronomic trait. For this reason, we try to develop our app that is Phrygian, so that if you hear, you sound like free genes, not only phenotype. Now in Rome, our situation was this one. So we print this big tab, and we go on the field, we field, and we come back in our studio and put all this data in the computer. All this situation is very prone to error and also is time consuming. For this reason, we want to try to digitalize all our data collection, also plant management and data networking, to the implementation and construction of a database. The databases have two different locations. One is on an industrial tablet, another one is on a desktop version on our PC. So we need an infrastructure that could host different data type and different information to put in one system only. For this reason, we think we focus on this data flow, and I don't know if you can see me now. Yes, perhaps yes. So we have this tag. This is an RFeed technology. So this is a tag that was guaranteed for 10 years and can help us to unique identify our trees. This is one of the most important steps to try to reduce the error that you can have trying to manage this huge number of plants. After that, we collect the trait in-house on the field, and we have a continuous synchronization from field to local database of our data. And at the end, we are now implementing the connection of our database to European and international platform to try to upload in continuous data. All this work was done in collaboration with another CREA research center for the informatic part. So our first goal was to replace the field notebook and reduce error and time on field laboratory measurement. So we have, this is the tag, is an RFeed tag. It means that it's a passive tag. We don't need energy to work it. And this is our tablet, and this is the type of data that we can handle with this application. So we have phenotypic trait that we can kept on field, but also phenotypic trait that we have on the lab. One of the major issue, this is our one of our peach germplasm collection, is to have this continuous flow of data from field to our database, and we have solved with the long-range wide area network that is an open access non-profit system, and it can able to cover a very long distance. So our signal is kept also 25 kilometers from the institute. So we can cover a very wide area, and it's free and is not a secondary point, and it can send a small package of data. What does it mean? It means that we can send number, but we cannot send at the moment pictures. But if unfortunately we are on the field and the tablet was broken or something happened, we don't have lose anything, any data. Now I want to show you the application first of all, and after that I try to show you performing a simulation. So when you open, now is in Italian, but we are now updating in English. You have two type of accession. You can read the RFeed, or you can manage the accession data. If you try to manage the accession, you have a list of all the accession that you have preloaded in your tablet, and you have this is the field position. This is the accession ID that we gave to the plant when we're introduced in our collection. And this is the DOI. We have the row and the number of the plants. We have the name of the genotypes, the species, and the scientific name. You can select your field of interest. You can select the species. And so you have a subset of all the trees that are present in this specific field for this species. And after that, you check one and you click to go to trait, and you go to see, we can see that later. You will see a list of characters that are preloaded. If you, another type of accession could be with RFeed. So you go near to the RFeed to the plant with the tablet, and the RFeed from red turn to green, and immediately they return some specific data. So again, field, row, plant, the DOI, the name, the species, the scientific name, and the data of introduction. When you have choose your genotypes, you have this user-friendly list of traits. These traits are mutuated from the InnOBreed process, because one of the most important things is to try to homogenize scale and data, to try to compare the data that we can collect in Rome with the data that you can collect all around Europe. And so you have this traffic light system. So yellow means to be completed, green is completing, and red is to do. You choose one, and when you open, you have the name, a priority, if you can take picture or not, and also you have a very precise description of the trait, and also the methodology, and in the comment you have the scale. So we know in this case we have a scale. We choose based on our evaluation the value of this phenotypic trait, and also we can put some notes to take note of something that that are important for our observation. After that, we save, and we saw that the color is yellow. We go to check trait completed in this box. We save again, and the color turn in green. If I will able to share a second screen, I will try. I will show you the app by Real. Okay. One moment. And okay. And I try to share my screen. Okay, I try to share my screen. One moment. Okay. So please work. Okay. And okay. So Sorry, it's a little bit slow. Sorry, the Wi-Fi it's very slow and the app it's heavy. Ah, I don't know why. I'm so sorry. Okay, I continue to show you on the screen. I really don't know why it didn't work, but we can also try to monitor the status of our collection. And so we select the species, and as you can see, you have a list of the fruit that of the trait that we need to evaluate, and with the same code of the traffic light. We have red for no evaluation at the moment, yellow we have evaluated but we are not sure we want to do something more, and green the trait is fully evaluated. And so we can select one specific trait depending on the phenological state and the time of the year. And we have a list of the sample. And so we can precisely know which are the sample that we need to evaluate. And after that, we can download all the data, selecting again which field we are interested for and which species. And we go to export data, and we have an Excel tab, and we have all the information linked to the plants, and also all the list of character that we have evaluated or not. And the second part important for us is the data sharing. So we need to not take all this data in our desk, and we need to are visible at the international level, also to try to use all these big amount of data to try to solve some common problem at international level. For this reason, we, the Phrygian database and app, respond to the FAIR protocol and principle, so findability, accessibility, interoperability, and reuse of the data. And at the moment, we are trying to connect with the different European platform. And to do that, we have this desktop version. In this case, using the desktop version, you can update the phenotypic trait or create new trait. You can consult and export, and also you can use you can introduce new genotypes, and also you can introduce new protocols. The important things that with the collaboration of our ET Center, this app can be easily used in all the fruit species. The prerequisite is that all the traits are in a tabular form, because we need to fulfill all these data. And also we decide and we said to maintain a previous version of the protocols. What does it mean? It means that if you decide to modify the evaluation of a specific pathology during this year, we know that in the 2020 we use version 1, in 2022 the version 2, to try to be robust, because our main goal is to be robust and to have a tool that is precisely designed to try to reduce all the problem and the error and the inconsistency that we can create during the evaluation protocol, because we need a very robust data set to try to solve our problem. And Phrygian was the result of a different project, not only InnOBreed. It was essential because the huge amount of efforts that we use to try to standardize all protocol are very, very important at not only European level, but is an important issue at international world level. And also we have two Italian projects, one that help us to maintain the collection, and the other one that helped us to build the infrastructure. And this is our research group. And thank you for the attention. And if I have 2 minutes left, I want to try to open again the app, if it's possible. Camille?
Yes, sure. You can try to.
I can try
to open it, and in the meantime, if you have questions, we can collect the questions.
Perfect. Perfect. Thank you so much.
Thank you for your presentation.
Sorry for this inconvenience.
No worries. So, are there any questions either for Elisa or Yann and Niklaus related to their tools?
I think that I can begin. It will be, I think, a mix between a roundtable and question and answer. We have separated that in the program, but I think it will be a mix of that. Perhaps I'm starting in order to break the ice, and feel free really to ask something, to ask some questions, and it would be good if you are presenting you before asking the question, and what are your main activity. Okay, I'm starting with you, Niklaus and Yann. The device, it will be the same question perhaps to Eliza after that. Your tool is dedicated to breeders. How do you assess the adaptability for genetic resources or collection curators or for evaluators in terms of accuracy of the data that are inside, in terms of number of traits that are evaluated, etc., etc. I think that the flexibility of your tools also for curators or variety evaluators, how would you assess that, this flexibility? Yann or Niklaus?
Yeah. We're gonna make a mix because you're gonna hear it.
You're
me,
muted. We
Niklaus.
are hearing the microphone of Niklaus, I guess.
Yeah, I know, and that's
okay, sorry.
That's right. Do you hear me well?
Yeah.
Okay, nice. The BreedersDB tool is actually, it's custom made for breeding programs, but actually you can just assess any cultivars or any data you want. And as I showed, you can define actually not limited amount of attributes that you can use in it. And therefore, I would say it's really adaptable. It's really adaptable in the form it has now. Genetic resource collection data might not use every single step we built in now, but it has for sure the possibility to assess its data there, and use the strongness of this tool. I don't find my word. Use this tool for it. And another thing is, it's an open source tool. This is possible to just develop it further. And it could be a really small thing to just add some specific features. And if you needed a support for it, then the person that developed it, Cyril Bolliger from Bolliger Tech, would be the contact person for it to just help you through that. But as I said, it's open source, so you can make it yourself if you get the know-how for it.
Yeah, we can give the floor also to Cyril Bolliger, the developer of this tool. Maybe he can complete what we already said.
Danilo?
So we are trying to unmute. Camille, you can perhaps try to unmute. Yeah, sorry, Eliza.
And for our point of view, this app
the flexibility,
is,
the question, perhaps the flexibility, it's dedicated to genetic resources, more or less, and how flexible or adaptable is it for variety evaluators or for breeders?
As you can see now, it works. I will show you something later. And It's highly flexible because, as you can see, you can put and try to insert trait whatever you want, and you can also insert different plants. So it's very, very flexible. And the objective is this one because as CREA, we are the biggest institution that maintain in Italy genetic resources from 200 different species. So in our ideas, we developed this one for fruit species, but in our idea is to adapt the database structure to all the species that are involved in genetic resources characterization. So it's very easy to adapt. And you have two ways. Now we are implementing a module to import directly an Excel table inside the app with all the character and all the plants. But at the moment, you can put one by one the plant and the trait. And we are inside the app. And sorry, but sharing is very slow. So I try to
Try.
open.
It's okay.
Yeah,
Take time to
it
try.
works now, but it's very slow. So if you go ahead with question, when I'm ready,
Okay.
I show you something.
Okay. We have a question from Jean-Marc. I don't know if you want to precise that. That's more or less the follow-up from one genotype, and then the follow-up with the favorite that are grafted and so on. Jean-Marc, you want to precise your question? Oh, perhaps you do not have the permission. Camille, did you?
Yes, I did.
Jean-Marc, you don't hear you.
Maybe in the meantime, I can answer to the question of Danilo about the adaptability of BreedersDB for variety evaluators, if that's fine for you. Just some quick details. It was used for variability evaluation in a project from Feeble. There for grapes, it worked pretty well. The system is built for millions of data points, so there should be no scalability issues, and you're free to add any number of traits or characteristics. So far, we didn't have any issues in production.
Okay, thank you. I think it's more or less the question also from Jean-Marc, the follow-up. Yeah, Jean-Marc cannot open the microphone. Camille, can you solve this?
I am trying to, yes.
Okay. So perhaps for the favorite good genotype, you are following the hybrid from one step to the other one, and from hybrid field also. It was more or less the same question, I guess, with the follow-up of one hybrid after grafting and so on. With more data, with repetitions, etc. If you have one favorite, can you in your database, Yann or Niklaus, follow the same hybrid with some description at the beginning, and then really enlarge the description, but with the same ID or hybrid or genotype, the same genotype? How do you manage this?
Yeah, this is actually really straightforward, because as I showed around the building of the names, we've got the first part of that makes the cultivar, the genotype actually. I could share my screen if it helps, just to show it. But
I think that let Eliza with
that's good
for the moment.
That's good. I
It's better.
think it's understandable. But if you got in this acronym, the first part is for the cultivar, and afterwards you can add a part for a group, and it could be the first step and the second step that you just change on the group, but the first part stays. That it means the data that you are collecting on the two entities that you are group 1 and group 2, let's say, is connected through its phenotype, and as a result, you can really follow it as you asked, through the steps of the evaluation or of the breeding.
Okay, thank you.
And
Jean-Marc, perhaps you can try again.
It works. Thanks. Thanks, Camille.
Sorry.
No, don't worry. Thank you for the two presentations. It was very interesting. So, well, okay, for the first question. My second question is also for the two presentations. Did you introduce in your database the possibility to characterize the environment factors? So do you give the possibility to have a metadata set dedicated to the environment factors integrated in the overall system?
If I can answer, in our case, in the desktop version, we have a module that can allow the weather condition. We have a weather station here in the center. We have two, and we can couple the weather condition with phenotypic data, and also using our system, we have the geolocalization of the plant in the field. So we have these two different metadata type.
Thanks.
And also, if I can add something that concerned the previous question, we have a system in which when we have an interesting cross or we have an interesting genotype and we need to multiply, or in the case of our collection when we are at the time that we need to duplicate the collection, we have sister code. So what does it mean? It means that we have a new RFID code, but that is linked to the previous one. So we have like we can trace all the movement that the Xion make during time.
Elisa, do you trace on that way also the multiplication phase in a nursery?
Yes.
By entering the coordinate of the mother plants? Okay.
Because at the moment, the multiplication of the plants was done by ourselves. Mm-hmm. So we also bought the rootstocks, and we take the sticks from the field and we make the grafting.
Yeah, because that's really useful.
Thank you. Niklaus, you want to answer the same question with integration of metadata?
Okay. We have the possibility to define the groups where we put the plants in. So we can, for example, define one group dry conditions, one group normal conditions. And with that system of the groups, we can afterward compare the data. But to complete, at the moment, we cannot just find actual meteorological data to it, but you've got the possibility to have a proxy for it through the place where the tree is, because this is registered, and then you know the place, and then you can pet it again with this data, but it's not built in natively now.
Thank you. I have another question, perhaps first to Eliza, and then I'm coming back to you, Niklaus and Yann. The question is external person. I think that what is interesting in that perhaps other institution can access also and use and so on and share the data. I think the goal is really to share the data not only within the different location of CREA, but also with other institutions. How far it's functioning good with external people, external from CREA, and secondly, you showed on your first slide genetic data. And can other institutions also access the genetic data of some of the genetic resources, or you have perhaps limited access for some of your data? So two part of questions.
Okay.
One part is accessibility of the data for everybody, and the second one, how many external persons are sharing, using your system and sharing their evaluations?
Okay, for the first one, we are at the beginning of our system. So for the moment, we are using inside our institution, but we have we are trying to have collaboration with at the regional level and some university are interested in this system. And from the technical point of view, the structure of the database is open source because we developed this one with a public research fund. So we don't have covered by any patenting or something like that. We need to sign a collaboration, and we can share the structure of the database. But in the institution that received the system, they need to have NET manager, because there are some updating or something that could need to be handled by an informatician, not by us.